Assalamualaikum. My name is Nur Amira Shazina, and now I will be presenting about the high performance liquid chromatography HPLC. There are 4 objectives in this experiment, such as to determine the amount of caffeine by calibration curve, to determine the retention time of the standard caffeine, to compare the retention time of sample with standard, and to observe the levels of caffeine that is allowed by Indonesian Standard Agency and FDA regulation with the approved caffeine content. Next, we move to introduction. High-performance liquid chromatography is a technique to separate, identify, and quantify components in a mixture. Caffeine is an alkaloid compound of xanthine, a naturally occurring chemical stimulant called trimethylxanthine, where the chemical formula is C8H10N4O2. In its pure form, caffeine is a white crystalline powder that tastes very bitter. It is medically useful to stimulate the heart and also serves as a mild diuretic, increasing urine production to flush fluid out of the body. Next, we move to the chemicals and apparatus. The chemicals that were used in this experiment are all solvents and reagents were analytical grade: chloroform, Dragendorf reagent, HCl, cobalt chloride, double distilled water, cobalt nitrate, methanol for liquid chromatography, and ethanol. The apparatus that were used are LC2080 HPLC instrument with SPD20A Shimadzu detector. HPLC conditions referred to the slight modification in mobile phase composition, for example reverse phase. C18 ODS column, detector set at 278 nanometer wavelength, flow rate 1 ml per minute at room temperature, 20 microliter of sample volume, and methanol motion phase, double distilled water with ratio 95:5. So this is the methodology for this experiment. We have sample collection, qualitative analysis, and also quantitative analysis. For sample collection, samples were obtained from several stores and were labeled with initials X, Y, and Z. For qualitative analysis, we have Dragendorf test and also perimetric. For Dragendorf test, a total of 1 ml of sample was dissolved in 10 ml of chloroform and 4 drops of NH4OH, then filtered, and the filtrate was inserted into a closed reaction tube. The chloroform extract in the test tube was shaken with 6 ml of H2SO4, 2 molarity, and the acid layer was separated into another test tube. This acid layer was dripped onto the drop plate and added Dragendorf reagent, which will cause the orange-red sediment. Perimeter analysis were performed by means of a number of substances dissolved in alcohol, then added peri reagent and diluted ammonia. The dark blue or green solution states that show caffeine exists. Peri reagents were made by reacting cobalt nitrate with methanol. For the last part in methodology is the quantitative analysis. The system suitability test was performed by injecting a standard solution caffeine 60 microgram per milliliter at 6 times in a predetermined HPLC system. The RST value is specified for the value of retention time, AUC and tailing factors value. The linearity test was performed by injecting the caffeine standard soluble in ethanol with concentration of 40, 60, 80, 100, 120, 140, 160, 180 and 200 microgram per milliliter, respectively, into the HPLC system. The standard curve was created between the concentration of caffeine standard and AUC. In order to determine the caffeine content in coffee beverage, 5 ml coffee sample was inserted in a separating funnel, then extracted 4 times each with 25 ml of chloroform addition. The bottom layer is taken. The extract chloroform layer is evaporated over the water bath until the chloroform evaporates entirely. The solvent-free caffeine extract is dissolved with ethanol up to 5 ml. The standard solution and sample were injected into HPLC system with HPLC conditions as follows: reverse phase C18 per ODS column, detector set at 278 nanometer wavelength, flow rate 1 ml per minute at room temperature, sample volume 20, 0 microliter and mobile phase methanol, double distilled water with ratio 95:5. The caffeine content is calculated with the linear regression equation, that is y equals to bx plus a from the standard calibration curve.
Data and analysis. Table 1. The result of Dragendorf test on coffee beverage. This table shows the data collected for Dragendorf test. In this test, the presence of alkali in the caffeine standard shows a positive result, where the clear sample will become brown precipitate as the Dragendorf reagent was added. Based on the table above, the other three samples X, Y, and Z shows a positive result too, which indicates that there is an alkali presence in those samples. As for the table 2, the result of Perry-method test of coffee beverage. The Perry method used to test the presence of caffeine compound in the sample. The compound that contains caffeine will have color changes from clear color to green color when the reagent was added. Because cobalt ion in the reagent is positive charge that will bind with the nitrogen group in the caffeine. Based on the data above, the X, Y, and Z sample give the positive result as the sample from green colored solution, which is the same as the caffeine standard sample, where this color change indicates the presence of caffeine compound in those. Next, this figure shows the chromatogram result from HPLC test that has been conducted on the standard coffee solution and other sample, which are A. Solvent, B. Caffeine standard solution, C. Sample X, D. Sample Y, and E. Sample Z. From the experiment, the average standard caffeine retention was 2.518 minutes, and the value for retention time for X, Y, and Z samples were 2.503 minutes, 2.493 minutes, and 2.493 minutes respectively. Based on this peak value, it can be seen that these three samples, X, Y, and Z, contain caffeine, as the peak value of the sample were relatively the same with the standard caffeine solution peak. The retention time from chromatogram figure 1. Let's move on to the table 3. The data shows the caffeine levels in the sample X, Y, and Z. Based on the data above, the mean value of caffeine level for each sample X, Y, and Z were 132.048 mg per bottle, 109.699 mg per bottle, and 147.669 mg per bottle respectively. Discussion. In chromatography, there is normal phase partition and reverse phase partition. The normal phase HPLC is usually when the stationary phase is polar and the mobile phase is non-polar. On the other hand, in reverse phase of HPLC, the properties of mobile and stationary phase are opposite, where the stationary phase is non-polar and the mobile phase is polar. In this experiment, the response factors is correction factors that needed in order to make the calculation of true value of analyzed concentration by using internal standard calibration. This is because the response factor used to represent the differences in response between the analyzed and the internal standard for a particular detector. In HPLC, the compounds that are suitable for the analysis are the compounds that are non-volatile and thermally unstable compounds, such as organic, inorganic compound, biological simple, synthetic or natural polymer, and thermal labile compound. In addition, gas chromatography GC and high-performance liquid chromatography HPLC can be differentiated with their mobile and stationary phase. In GC, the mobile phase is gas and the stationary phase is usually solid or liquid, while for the HPLC, the mobile phase is polar solvent liquid and the stationary phase is liquid supported on a solid or HPLC column.
About the data analysis. In this data analysis, I would like to continue about the qualitative analysis and also quantitative analysis. Firstly, qualitative analysis is done by comparing the retention time of caffeine standard solution with the sample X, Y, and Z. From the chromatogram, X-axis is the retention time, which is the time between the injection of the analyte to the detection of the analyte. Based on the chromatogram, retention time for the caffeine standard is about 2.518 minutes, sample X 2.503 minutes, and both sample Y and Z have the same retention time about 2.493 minutes. Next, qualitative analysis is done in sample X, Y, and Z that show a positive result with dragon dove by the presence of alkaloid compound when compared to the caffeine standard pure compound. This is the caffeine peak, A for solvent, B for caffeine standard solution, C X, D compound Y, and E for Z. So for B, caffeine peak is about 2.518 minutes, show the retention time. And this is the caffeine peak for X 2.4503, D 2.493, same with the E. This is Y and Z. So to compare, the value is not really different. It's slightly not really different, slightly the same. And next, the qualitative analysis is done by using Perry test. So the observation does show that sample X, Y, and Z have the presence of caffeine, as they have a similar result with the standard caffeine with the observation from the color. So the color turned from clear to green. So this is the analyte present in the compound, which is caffeine, the structure of caffeine. The quantitative analysis is we want to determine the caffeine content in the coffee beverage. So caffeine content is calculated by standard calibration curve. In this, we can get linear regression equity y equal to bx plus a. From the curve, linear regression equation can be obtained, which is y equal to 15044 x plus 231,298.87. This is a table showing that caffeine level in sample X, Y, and Z. So the mean is about 132.048 milligram per bottle, and for Y 109.699 milligram per bottle. Lastly, for Z 147.669 milligram per bottle. So from the mean average constituent of caffeine in the sample shows that the level of caffeine contained in the X, Y, and Z coffee beverage are not comply with the Indonesian Standard Agency regulation for one serving coffee, as it exceed the amount that is allowed. The amount of caffeine in a soft drink is also can be determined by using response factor formula. The formula is the response factor of caffeine standard is equal to peak area caffeine standard divided by concentration of caffeine standard. So the concentration of caffeine in the unknown sample can be obtained by peak area of caffeine in unknown sample divided by the response factor. So the concentration of caffeine in X is equal to 132.048 mg per bottle. The concentration of caffeine in Y 109.699 mg per bottle. And lastly, the concentration of caffeine in Z is equal to 147.699 mg per bottle.
The purpose of this experiment is to determine the level of caffeine in coffee beverage with HPLC method. The important components of HPLC are a pump, injector, column, and detector. The ratio of methanol and water are 75:5 that act as mobile phase, while ODS act as stationary phase, and UV 272 nanometer act as detector. In this experiment, the amount of caffeine in coffee has been determined and reverse phase HPLC can be used to determine it. The level of caffeine data was statistically analyzed using ANOVA at 75% confidence level.
Lastly, the discussion, what is the possible error and how to overcome? Firstly, there might be a fluctuation in the flow rate caused by the fluctuation in the pump operation. So, there must be a regular check to track the pump operation. Next, variation in column temperature. The temperature must be controlled just by a slight difference, so they can reduce the variation in the column temperature. And lastly, contamination might be occurred. So the solvent must be free from the dust impurity as it will damage the pumping and the injection system by the filtration through the membrane.
And the last one is conclusion. By conducting the experiment, we were able to determine the amount of caffeine by calibration curve. Besides, we were able to determine the retention time of a standard caffeine. Next, we were able to compare the retention time of sample with standard. And lastly, we were able to observe the levels of caffeine that is allowed by Indonesian Standard Agency and FDA regulation with the approved caffeine content. That's all from us. Thank you.